Okay, so we're predicting products of chemical reactions on pages 10 and 11 in your packet. We are going to do 12 and 13 together in class to finish out the last few types of reactions. But before we actually get to predicting products, we're going to be writing formulas and equations. So one more time, I'm going to remind you of those 7 diatomic elements that can never be alone. If you do try and make them alone, you need to add that 2 on them. Those 7 elements are my Brinkelhoff elements. Or you might remember them as the I bring clay for our new house elements, because every single one of those words starts with a symbol of one of those diatomic elements. And it seems like everyone's favorite is to look at the periodic table and start at element 7, make a 7, and don't forget hydrogen. But whatever way you remember it, write it down, and remember them. It's important. Now, when elements aren't in their elemental form, they're in a compound, we need to make sure we're still writing the correct formulas of those compounds. Now, as we're predicting products today, these compounds that I'm going to ask you to write are all going to be ionic. So, in order to make sure the formula is correct, you need to make sure the charges cancel out. And that's basically it. So, let's look at these types of reactions we've talked about and how each of their products can be predicted. We're going to start with combustion reactions, honestly because they're the easiest. We always have a fuel, and that fuel is burning. And in order to burn, we need to have oxygen, which is a diatomic, and we always make the same 2 things, CO2 and H2O. Those are always my products, and so when I'm predicting products, these are the easiest because the products never change. So, anytime I tell you that we are doing a combustion of something, that's really all I have to tell you. The rest of it comes from you. These should be the easiest, but sometimes because I give you so little, people just forget what to do with that. But if you see any of these words, combustion, of course, anything about fire, burning, I ignited methane, or whatever it is, that means it is combustion. And whatever that is you have, in this first example, it's CH4, has to be in the presence of oxygen to do that combustion, that burning. And combustion always makes those same 2 things, CO2 and H2O. So that's my reaction. And if I balance it, because it does ask me to balance it up there, C's are already good. I need a 2 here to balance H's, and a 2 there to balance my O's. And now I'm done. Well, I have this next problem to do. Propane is a different fuel, but the rest of this reaction is exactly the same. And now I just have to balance it. 3 CO2 to get those carbons balanced, 4 H2O to balance out those H's, and then I've got my split oxygens. I need to count. Over here I have 6, over there I have 4, so that side has 10 total. Okay, I can get 10 on my reactant side with a 5 there. So, now I'm done, and I need you to finish out this page with these other 2 fuels, and that should be the only thing that changes about this reaction. Just swap out the other fuel, that methane and that propane, for these new ethyl alcohol and octane, and then balance them. That last one is a little bit fun to balance, but remember your odd-even rule and you'll be fine. Now, on the next page, page 11, at the top we're talking about how to predict products of synthesis reactions. And if you remember, synthesis reactions all come together to make one compound, one product. And it can be elements or compounds coming together to make that compound. Technically, all synthesis reactions are very diverse, but in the reactions we're asking you to predict products of, we are only going to give you elements that create ionic compounds. So, that way, you can check the charges and make sure you've written those formulas correctly. So, if we look at this first example, Mg and O2 are coming together, and it is a synthesis reaction because I'm just starting with 2 elements. All they can do is come together, so I'm just going to squish them together, MgO. Now, I am writing a formula, so I do need to check charges. Mg has a +2 charge, O has a -2. So hey, guess what? Shoving them together actually worked. Those canceled out. That is my product. Now all I have to do is balance this reaction. Get 2 O's on this side and fix my Mg's on that side, and we're good. Next one, with lithium and oxygen synthesizing a compound, I'm going to start by shoving them together. LiO. Check my charges. Lithium is a +1. Oxygen is a -2. Ooh, those don't cancel. So I'm going to go ahead and switch them. Bring this one over here, this one over there. And my new formula is Li2O. So I shoved them together, and then I just added that little subscript in there. And that's my product. Now I just need to balance my equation. Li's need to be balanced with a 2, and then a 2 over there for the oxygens, but then that messed up my Li, so here we go again. Now that one is done. If I start looking at the next one, my instinct is going to be to start shoving Fe and Cl together, and that does happen, but then I start trying to check the charges, and I go, oh, iron's a transition metal. I have no idea what its charge is. Well, in general, we're going to tell you, for this unit, to assume that those transition metals have a charge of 2. But we will tell you if that element does like to have a different charge. But in general, just guess 2. Here, this is one of those times where I'm going to tell you that iron actually likes to be a +3 charge. It mentions right here that we always are going to assume that that iron or whatever that element is taking the highest oxidation number possible. So because iron can be more than a +2, it's going to go for it. And I'm actually going to switch back to red because that blue just kind of blends in. But if iron is a +3 because Mrs. Gunter says so, chlorine is a -1 because the periodic table says so, they don't cancel, so I switch them, and that turns my formula into FeCl3. Now, balancing that, I have a 2,3 with that chlorine, but I can make that 3 side even by putting a 2 in front of it. And then to get 6 chlorines on the other side, I need a 3, and of course a 2 in front of that iron to make those balanced. So, all good. Technically, H2 and O2 aren't going to come together to make an ionic compound, but I'm pretty sure you can still predict what they will make. H2O, water, of course. You saw this in our demo day. So that's the only covalent compound I'm going to ask you to predict. You should really know what water is and that it's made from hydrogen and oxygen. Yeah, get on that. But balancing this out, and I'm done. Yay! Now, let's move on to our last type of reaction, predicting products of decomposition. Now, decomposition is the opposite of synthesis. It starts with one compound, only one reactant, and all that it can do is break that compound down. So, just like synthesis, we're going to keep these reactions a little simpler, and we're only going to ask you to decompose a compound down to the elements. It's not going to stop and break down from a big compound into smaller compounds. So, we are breaking things down into elements, which means I need to check my diatomics and make sure when I try and force something to be alone that it doesn't need a buddy. But we'll check those as we go. All we need to do when you see a compound like MgO decomposing, it's the only thing that's there, so it has to break down, is I'm going to start by pulling that stuff apart. I have Mg and O separately now. And I'm going to check my diatomics. Mg is not a diatomic, yay. O is, so I add a little 2 onto it. Those are my products. Now to balance that reaction, I need a little 2 over here, then a 2 over there, and we're all good. Next one is the same process. I have H and Cl together, and that's it. So all they have to do is break apart. H is going to be separate from that Cl now, although it is a diatomic, so I'm going to add the 2 there. And Cl is now separate, but it's also a diatomic, so it also gets a 2. So that's my products. And just to balance, I'm going to put that 2 up front. Pretty quick and done. And yes, I am done. And you need to do a couple more problems to be done. And it should only take you about 30 seconds, maybe a minute, maybe 2. But you do need to finish out these last 3 decomposition reactions and balance them if you want to get a stamp. So, do it. Have a great weekend. Be safe, guys.